Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and you are doing well and your studies are also going on well. In this part 17 video from the chapter of Herons Formula, I will be solving set 3 of 5 conceptual problems. These are revision problems based on the entire concept of the chapter. This video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so the first problem says the base of an isosceles triangle measures 24 centimeter and its area is 192 centimeter square. Then the perimeter of the triangle is, okay, so let's say this is an isosceles triangle ABC. Let's say BC is the base and the equal sides are AB and AC. Okay, the base is given to be 24 centimeter. Okay, 24 centimeter. BC is 24 centimeter and the area is given to be 192 centimeter square. Now we have to find the perimeter. To find the perimeter, we need to know one of the length of the equal sides AB and BC. How do we know that? The concept is that from the we are given the area and we are given the base BC. So from that we can find the length of the altitude on the side BC from the vertex A. Let's say AO is the altitude or perpendicular distance on the side BC from the vertex A. So AO will be the altitude of the triangle ABC corresponding to the side BC or base BC. Okay, so we can have then the area of the triangle will be half BC multiplied by AO should be equal to 192. I will not be mentioning the units. I hope you will understand. This implies that AO will be equal to 2 multiplied by 192 divided by BC. This is equal to 2 multiplied by 192 divided by 24. This is how much is this? 12. I think this is 12 and this is 16. So this is 16. Okay, that is 16 centimeter. Okay, AO is 16 centimeter. Okay, now since ABC is an isosceles triangle and AO is perpendicular to BC, then AO will also bisect BC. So let's say AO will bisect BC. So we must have AO, we must have BO should be equal to OC. So this implies OC is equal to BC by 2, which is equal to 24 divided by 2, which is equal to 12. So OC is 12. Now in the right angle triangle, AOC, the objective is to find the length of the equal sides AB and BC. So I am considering the right angle triangle AOC. Using Pythagoras theorem, I will be able to find the length of hypotenuse AC. So we know AC square will be equal to AO square plus OC square. AO is, we have found AO to be 16. So 16 square plus OC is 12. So 12 square. This is 256 plus 144. This is equal to 400. AC square is 400. So this implies AC is equal to square root of 400, which is 20. So then the length of AC is 20. So we have found, now we know the length of all the sides of the triangle. So therefore the perimeter will be AB plus BC plus twice AC, AC, which is equal to, I can say, 2 into AC plus BC which is 2 multiplied by AC is 20 and BC is 24. So this is equal to 64. So the perimeter of the triangle is 64 centimeter. So the correct choice is A. Now, if I am doing any kind of silly mistake or calculation mistake and coming up with wrong results, then please feel free to let me know in the comment section. I will highly appreciate that. And if you have any query regarding any step, any concept I am applying, if you do not understand anything, also let me know in the comment section. I will do my best to address your query. Let's see the next problem. Question number 2. The perimeter of an equilateral triangle is 150 meter if its area is 25 square root of 3 multiplied by k meter square, then the value of k is. So we know a perimeter is given. So perimeter of an equilateral triangle we know is thrice A, where A is the length of each side of a triangle. So this is given to be 150. This implies A will be equal to 150 by 3, which is 50. Now please note that I am ignoring the units. I hope you will understand. A is 50. Okay. So this implies area, we know area of an equilateral triangle of side length A is square root of 3 by 4 A square. This is equal to square root of 3 by 4, and what is A? A square is 50 square. So this is equal to okay. So this is equal to 25. 50 square I can write it as 50 is 25 into 2. So 50 square I can write it as 25 square multiplied by 2 square, and I have multiplied by square root of 3 divided by 4. So 4 and 2 square cancels out, and I have 25 square multiplied by 3. So this I can write as 25 square root of 3 multiplied by 25. So clearly this is equal to given as 25 square root of 3 into k. So this implies that k is equal to 25. So the correct choice is B. B is the correct choice. Let's see the next problem. Question number 3. Find the ratio of the area of the shaded region to the area of the quadrilateral ABCD. So ABCD is a quadrilateral. Okay. You have to study the diagram carefully and what information we are given. So we can see that AD we can see in triangle. We have to find the area of the quadrilateral ABCD, ratio of the area of the shaded region, which is triangle ABC. So we have to eventually find the ratio of the triangle ABC and area of the quadrilateral ABCD. Okay. So we know the length of all the sides of the triangle ABC. So let's say this B, I am considering A1. I am considering A1 to be the length, to be the area of the triangle ABC, and A2 to be the area of the quadrilateral ABCD. So what is A1? To find the area of the triangle ABC, A1, first using Heron's formula, we will find the semi-perimeter. So for triangle ABC, the semi-perimeter will be equal to the sum of the length of the sides, 28 plus 20 plus 24 divided by 2. This is equal to 48. 48 and 72 by 2 is 36. So semi-perimeter is 36. So then A1 using Heron's formula will be S multiplied by S minus 28 multiplied by S minus 24 multiplied by S minus 20. This is equal to square root of S is 36. So this is 36 minus 28 multiplied by 36 minus 24 multiplied by 36 minus 20. So this is equal to 36 multiplied by 36 minus 28 is 8, 36 minus 24 is 12, 36 minus 20 is 16. Okay, so this is equal to square root of 36 is 6 square, 16 is 4 square, and 8 into 12 is 96, 12 is 4 into 3, okay, so 8 is 4 into 2, so this is, if I club 8 into 12, it will be 8 is 4 into 2 and 4, okay, so this is 4 square multiplied by 6. So this now becomes 6 into 4 into 4 multiplied by square root of 6. This is equal to 96 square root of 6. This is the area of the triangle ABC. Okay. Now, how do we find the area of the quadrilateral ABCD? ABCD. Note that AD in triangle ACG, in triangle ACG, ABCD, okay. Okay, so in triangle ACG, we see that AD is equal to DG. Now, to find the area of the quadrilateral ABCD, we know the area of the triangle ABC. The area of the triangle ABC, quadrilateral ABCD, will be area of the triangle ABC plus the area of the triangle ACD. So A2 is area of triangle ABC plus area of triangle ACD. So the objective is to find the area of triangle ABC. We know, we have found area. To find the area of the triangle ACD, we note that, we observe that in triangle ACG, AD is equal to DG. This implies that CD is a median. Now this is an important concept. You must know that a median in a triangle divides the triangle into two parts of equal area. So we must have area of triangle ACD should be equal to area of triangle DCG. This implies, we can say that area of triangle ACD will be equal to half area of the triangle ACG. We can easily find the area of the triangle ACG because we know the length of all the sides. We know the length of all the sides of the triangle ACG. So let's see, let's find the area of triangle ACG. So for triangle ACG, what is the semi-perimeter? Semi-perimeter is AG is 40 centimeter. So 40 plus 24 plus 32 whole divided by 2. So this is 56, 96 divided by 2 is 48. AC is 48, semi-perimeter for triangle ACG. Okay, then area of triangle ACG, will be equal to square root of S, which is 48, multiplied by 48 minus 40 is 8, 48 minus 24 is 24, and 48 minus 32 is 16. So this is 48. Okay, 48 is 4 into 12. Okay, so 48 is 24 into 2. So we have 24 square multiplied by 16. I think this is 24 square multiplied by 16 square. So this is equal to 24 multiplied by 16, which is, I will use the calculator. 24 multiplied by 16 is 384. 384 is the area of the triangle ACG. Then the area of the triangle ACD, the area of the triangle ACD is half the area of the triangle ACG, will be 384 by 2, which is 192. 192 is the area of the triangle ACG. Okay. ACD, sorry, area of triangle ACD is 192. Then what is A2? A2 is, then area of triangle ABC is, area of triangle ABC is 96 square root of 6 plus area of triangle ACD is, we have found to be 192. So then what will be the ratio? This ratio A1 by A2 will be, A1 is 192 divided by A2 is 96 square root of 6 plus 192. Okay. Now we have to simplify this ratio. 192 divided by 96. Okay. 96. So if I divide, so 96 divides 192 by 2. So if I divide both the numerator and the denominator with 96, this will become 2 by square root of 6 plus 2. So the ratio should be 2 is to 2 plus square root of 6. 2 is to 2 plus square root of 6. Okay. So I think we have to further simplify this. If I square root of 6, square root of 2, square root of 3, 2 plus square root of 6. If I divide this ratio, both the parts, by square root of 2, I will have, this is equal to square root of 2 is to square root of 2 is to square root of plus square root of 3. Square root of 2 is to square root of 2 plus square root of 3. Square root of 3. Oh, okay. So basically, so we are having square root of 2. I'm having no space. So square root. So we have simplified the ratio to be square root of 2 is to square root of 2 plus square root of 3. This if I now multiply these both the parts of the ratio with square root of 3, I get square root of 6 is to square root of 6 plus, sorry, yes, square root. If I multiply this ratio, both the parts of this ratio with square root of 3, I get square root of 6 is to square root of 6 is to plus 3. So square root of 6, this is the ratio. Square root of 6 is to square root of 3 plus square root of 6 plus 3. So the correct choice is C. C is the correct choice. Okay, let's see the next problem. PQRS is a rhombus inscribed in a rectangle ABCD whose diagonals are in the ratio 2:3. Okay, so the ratio of the diagonals of the rhombus PQRS is 2:3 and has an area of A. So PQRS is a rhombus inscribed in a rectangle ABCD whose diagonals are I think the problem statement is little confusing. It is not really clear whether the ratio of the diagonals of the rectangle or rhombus is 2:3 and the area A is of the rectangle or the rhombus. I think it is of the rhombus. So the area of the rhombus PQRS is A, and so it is given area of PQRS, which is the rhombus, is given to be A. And let's say if we draw the diagonals of the rhombus, let's say it is given PR is to QS is given as 2:3. Okay. Then the perimeter of the rectangle ABCD is, we have to find the perimeter of the rectangle ABCD. Okay. So to know the perimeter, to find the perimeter of the rectangle ABCD, clearly we need to know either the length of the width and length, or the sum of the length or width. We know perimeter of a rectangle is 2 into length plus breadth. Either we know L plus B, or we know L and B individually. Now PQRS is a rhombus inscribed in a rectangle. Now this means if a rhombus is inscribed in a rectangle, then clearly it will mean that P is the midpoint of AD, Q is the midpoint of AB, R is the midpoint of BC, and S is the midpoint of DC. So in alternatively, in the other way around, I can say if you join the midpoints of a rectangle, if you join the midpoints of all the sides of a rectangle, a rhombus is formed. Okay, so we clearly have, we can say that, and so AD, the length of the rectangle, let's say L, if we consider the L to be the length of the rectangle, which is AD, will be equal to twice AP, which is equal to, I can say, twice QS, because obviously QS is parallel to AD, since and QS is also parallel to BC. So twice of AP will be equal to twice of QS, because the diagonals of a rhombus bisect each other at right angles, of course. So if P is the midpoint of AD, then obviously O is also the midpoint of QS. So we will have AP, which is equal to AO, QO should be equal to okay. So AP then is equal to L is equal to twice AP, okay, and this is equal to twice, not QS but twice QO, which is equal to basically QS, which is obvious that the length of the length AD, the side length of the side AD of the rectangle will be equal to the diagonal QS, and DC, the width of the rectangle, will be equal to the diagonal PR. Okay. Now, so can we find the length of the diagonals of the rhombus? Okay, let's see. We know, so what will be the area of the rhombus? What will be the area of the rhombus PQRS? We know its area is half multiplied by the product of the length of the diagonals. So it will be half multiplied by PR multiplied by QS. Okay. Also the ratio of the diagonals of the rhombus is given to be 2:3. So let's say based on this ratio, let's say I am assuming PR to be equal to 2x and QS is equal to 3x. Then the area of the rhombus PQRS will be half into PR into QS. This will be equal to 6x square by 2, which is 3x square. So this implies the area of the rhombus is given to be A. So we have 3x square is equal to A. This implies x square is equal to A by 3, or we can say x is equal to square root of a divided by square root of 3. We have to find the perimeter of the rectangle. Okay. So basically we need to know the length of the diagonals of the rhombus. So then x is square root of a divided by square root of 3, which we can write it as, if I simplify, it is always recommended that you do not keep irrational numbers in the denominator, always keep integer in the denominator, or any always rationalize any irrational number in the denominator by multiplying with that same irrational number. So this is equal to square root of a multiplied by square root of 3 divided by square root of 3 multiplied by square root of 3. This becomes square root of thrice a by 3. Okay. So x is this. So this implies what is PR? PR was twice x, which is equal to 2 into square root of thrice a by 3. And what is QS? QS is equal to 3x. This is equal to square root of 3a. QS is 3x. Okay. Then what will be? So what is the length of? What is the perimeter of the rectangle? So perimeter will be equal to 2 into AD plus DC. AD plus DC, because AD is the length of the rectangle and DC is the width, which is equal to 2 into so DC is equals PR. So DC is equals to PR, and PR we have found to be 2 into square root of 3a by 3, and DC and AD is equal to QS, and QS we have found to be square root of thrice a. So then the perimeter becomes AD is square root of 3a plus DC is twice into square root of 3a by 3. So this is equal to, what is the perimeter? Then the perimeter of the rectangle is, okay, so the perimeter becomes 2 into, if I simplify this expression, it becomes 5 into square root of 3a divided by 3. So this is equal to 10 into square root of thrice a by 3. This should be the perimeter of the rectangle ABCD. So the correct choice is B. B is the correct choice. Let's see the next problem, the last problem. Question number 5. ABCD is a parallelogram and O is a point on the side AD such that AO is to OD is M is to N. If the area of triangle BOC is x meter square, then the area of triangle AOB is in meter square. Okay. We are given that the area of triangle BOC is x. Okay. I am ignoring the units. I hope you will understand. We have to find the area of the triangle AOB. Okay. So it is a parallelogram. Okay. The ratio of AO by OD is given as M by N. Okay. Now, to find the area of the triangle AOB, obviously we need to find a relation between the area of triangle AOB and the triangle BOC. Now first of all, note that O, the triangle BOC and the parallelogram ABCD is lying on the same base BC and also between the same parallel lines AD and BC. O is a point, the vertex O of the triangle OBC is on the side AD and AD is parallel to BC. So we can say that the triangle OBC and the parallelogram ABCD is lying on the same base BC and between the same parallel lines, which means that area of triangle AOB is equal to half the area of ABCD, that is the parallelogram ABCD. Now, if this is so, we know that area of triangle AOB plus area okay, so area of triangle AOB plus area of triangle BOC plus area of triangle OCD is equal to area of triangle ABCD. Okay, so this implies area of triangle AOB is half of area of triangle ABCD. So I can say this is area of ABCD divided by 2 plus oh, I did a mistake. Area of triangle AOB is equal to half of area of, no, this is wrong. Area of triangle BOC, area of triangle BOC will be equal to half the area of triangle ABCD. Now let's use some notations so that it will be easy to refer. So let's say okay, so let area of triangle AOB be equal to A1, let area of triangle BOC be equal to A2, and let area of triangle OCD be equal to A3. Okay. Now clearly the area of triangle BOC A2 is equal to, and let's say the area of the triangle ABCD, area of the parallelogram ABCD be equal to A. So then A2, the area of triangle BOC we know is half of area of triangle ABCD. So A2 will be equal to A by 2. Okay. Also we will have area of triangle ABO, which is A1, plus area of triangle BOC, which is A2, plus area of triangle OCD, which is A3. This sum should be equal to A. So this implies that okay, A2 is A by 2. So we have A1 plus A by 2 plus A3 is equal to A. This implies A1 plus A3 is equal to A minus A by 2, which is equal to A by 2. So obviously the area, sum of the area of the triangle ABO and triangle OCD is half the area of the parallelogram ABCD. Now we have to find the area of the triangle AOB. Okay, AOB. We know A1 plus A3, so area of triangle AOB is A1. We have to find A1. Now again, please note that if I draw a perpendicular from the point O, so on the side BC, so let's say this is OT. So OT is the altitude of the parallelogram ABCD. It is also the altitude of the triangle BOC as well as triangle ABO as well as triangle OCD. So I can say that A1, that is the area of triangle ABO, will be equal to half multiplied by OT multiplied by AO. Again, the area of the triangle OCD, that is A3, is equal to half multiplied by OD multiplied by OT. So this implies that A1 by A3 is equal to half OT will cancel out. This is AO by OD, and AO by OD is given as M by N. So we know the ratio of A1 and A3, and we know the sum of A1 and A3. So clearly from the concept of ratio and proportion we can find A1. When we know that A1 plus A3 is A by 2, and when we know A1 by A3 is M by N, we can clearly say A1 plus A3 is equal to A by 2, and A1 by A3 is equal to M by N. This clearly from the concept of ratio and proportion I can say A1 is equal to M by M plus N multiplied by A by 2. Okay, A by 2. What is capital A? What was capital A? Capital A was the area of the parallelogram ABCD. Now the area of the triangle BOC is given as x. We have to find in terms of x. Now what is A? Area of the parallelogram ABCD is twice the area of the triangle BOC. So A is actually twice x. So this is equal to M by M plus N multiplied by twice x by 2. This is equal to mx by M plus N. So the area of the triangle AOB is equal to mx by M plus N. So the correct choice is D. D is the correct choice. So with this it comes to an end in solving another set of 5 conceptual problems on the entire concept of entire chapter Heron's formula. I hope solving this video will give you a good clarity of applying your concepts of this chapter to solve this kind of problem. So if you find this video beneficial, please like it, share it with your friends, and please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I think I will make probably one more video of solving 5 conceptual problems on this chapter, and then I will move on to the another new chapter. I don't know which chapter, let's see. So I'm ending the video here. Thanks for watching, and until the next video, take care and bye.